Okay, this is part 2 of the convolution question. In this case, xn is a two-sided sequence, 1 over 2, 1, 1 over 2, and hn is 1, 1. Okay, n is equal to 0 here, n is equal to 0 here. In this case, the length of y, the convolution, is 3 plus 2 minus 1, so 4. Okay, so 4. Length of y is 3 plus 2 minus 1. So we have to use a 4-point DFT. Hn is the DFT hk of Hn is calculated as very similar to the previous case, summation n from 0 to 1 Hn e to the minus j 2 pi k n divided by capital N. N is 4. N is 4. So it is 1 plus 1 e to the minus j 2 pi n is 1 divided by 4k. Okay, so this is my hk, and k goes from 0, 1 to up to 3. Okay, now xk. For xk, we can calculate the DFT of x tilde k, which is periodically shifted version of xn. I explained this in a previous video, but we can also do the same to this summation n from minus 1 to 2. We have to have 4 terms within the summation. Xn e to the minus j 2 pi k n over 4. This is the same as summation n from 0 to 3 x tilde n e to the minus j 2 pi k n over 4, where x tilde n is 1 over 2, 0, 1 over 2. This is n is equal to 0. Okay, so this is a periodically shifted version of this sequence here. Now, let's calculate xk using the first expression. Okay, xk, it is equal to 1 over 2 e to the plus j 2 pi k n is minus 1, so it's plus 4 plus 1 plus 1 over 2 e to the minus j 2 pi k over 4. Okay, so this is xk. Let me now calculate the DFT using this formula, which is the periodically shifted one. Let me call this x tilde k. X tilde k. Okay, it starts with 1 plus 1 over 2 e to the minus j 2 pi k over 4 plus 0. This is due to the 0 here, plus 1 over 2 e to the minus j 2 pi. K is now 0, 1, 2, 3. K is 3. Okay, divided by 4. Okay, now you can easily show that this is equal to this. Okay, e to the minus j 2 pi k over 4. E to the, e to the 1 over 2 e to the j 2 pi k over 4 is equal to 1 over 2 e to the minus j 2 pi 3. I forgot to put k here. 3k over 4. Okay, this is equal to that for all k values. Anyway, so k goes from 0, 1, 2, and 3. Then you multiply xk or x tilde k and hk. To get yk. K goes from 0, 1, 2, 3. And then you calculate yn using the inverse DFT, 4-point DFT of y, capital Y, to get yn. Okay, so that's it. Once you do that, but the sequence that you will get after this operation will be okay. Let me adjust my screen. 3 over 2, 3 over 2, 1 over 2, 0, is it 0? No, let me just calculate the convolution. 1 over 2, 3 over 2, okay, 3 over 2, another 3 over 2, 1 over 2, and then 1 over 2 in MATLAB. If you use MATLAB, yn will be like this. So this is n is equal to 0. This is n is equal to 2. Now this 1 over 2 is n is equal to, it's not n is equal to 3, it's n is equal to minus 1 in real convolution, because xn is an anti-causal sequence. Therefore, we have a periodicity of 4 in discrete time convolution. So actual y0, y of minus 1 is 1 over 2, y0 is 3 over 2, y1 is 3 over 2, and y2 is 1 over 2 as a result of this convolution. Now, if you let me repeat, in MATLAB, if you want to implement this problem in MATLAB, you calculate HK as usual. Okay, you implement this, and then you implement x FFT of x tilde 4, then y is h inner product or dot product x. Okay, then little y, you get a little y, which is I FFT of capital Y 4. Then you will get a sequence like this: 3 over 2, 3 over 2, 1 over 2, 1 over 2, and this 1 over 2 is the first value of the convolution, and it is y of minus 1. You see, take a look at the original sequences here. When you first perform the convolution, let me adjust the screen. The first value of the convolution is 1 over 2 due to this x of minus 1, and y of that happens at y of minus 1. Therefore, y of minus 1 is the y 3 in MATLAB based or convolution, which uses the standard form of DFT, which is this one. So everything, remember, everything is periodic by n in DFT and inverse DFT.